Hello YouTube, this is Philip20 again today, and I'm really excited. I'm going to do a test, but it is extremely dangerous and unnecessary for anybody to try to do one of these tests. This is a solar air conditioning test. I'm going to give a shout out to Yankee4 for bringing this up. A lot of people don't understand the difference between BTUs and watts. So we're going to find out. And just for the record, a BTU is a thermal, it's a British thermal unit, and it's a measurement of increasing the temperature of 1 pound of water 1 degree. So if you didn't know, now you know. What I'm going to do is I'm going to start a 42,000 BTU air conditioner. That's right. I'm going to run my air conditioner off of my solar array. And if it works, it works. And if it don't, I fail. But we're going to find out, and we're going to find out right now. How we can do this simple and easily is hard to explain. But this bar here is the main. This runs all of the circuits. This runs back to the inverter. And if I power this right now with the inverter, it's going to backfeed to the inverter and blow it up. I'm going to take this whole breaker out. No need for that right now. So, we got that breaker out. This powers this breaker here. Now, I'm running off the inverter currently. If I take this bar out, right here, and flip it on, this panel gets powered as well. And hence to say, I could run my stove, etc., 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 as long as this is off. If this is on, it's going to blow up my inverter. Let's tape it shut. I'll be right back for that. Actually, I got some tape right over here at the truck. Let's go over here. Grab some red electric tape. That means don't turn it on. Leave it alone. Now, we just put red electric tape right there. Now, we got the bar off, and we're running off of a 6,000 watt Ames pure sine wave inverter. Now, a lot of people, they shame the inverter. I mean, maybe they quit, maybe they don't, whatever the deal is, I don't know. But if I take this bar off right now, and this breaker down, and this breaker out, I don't think I'm going to have any problems. If I had this breaker in, it's probably going to destroy the inverter. If I had that breaker on, it's probably going to destroy the inverter. I'll find out in just a second. Okay, I've disconnected the bar. These two pieces of metal are a pain in the butt to get back in, so I'm going to power up this system. So we're going to see what's going on here. Now, this power is being fed by this box too, which is a no-brainer. Never do this. Let's go look at our current load. We're running the battery charger. I'm going to turn this off. Unplug it. We're probably running the refrigerator, etc., etc. We're under a 4% load. Let's see if the air conditioner will run. Now, this circuit was previously on my other one. I'm going to turn this down. We're going to see if it starts. And I'm currently at 73% battery capacity. We're going to find out if I can run a house air conditioner at my house with the main off. And we're going to do a test with this new meter. Of course, I don't like this one for some reason. This meter itself, I don't like it. I wonder which one of these is my outdoor unit. This one or this one? I'd say it's this one. Okay, now. I'm having a hard time. Oh, I took the battery out of this the other day. I'll have to use the other meter. So it's got a 5-minute time delay before the air conditioner is going to start. We're going to find out how it's going to work. The 5-minute time delay started when I flipped this breaker on and powered that circuit upstairs. I can hear the refrigerator running. Let's do a test on how many amps we're currently pulling with our inverter. So right now we got 3.3 and 1.3. So you got to add those together because this is a split phase inverter. So let's just go outside and look at the outdoor unit. I'm going to bring this meter and a screwdriver, and we can also do another test on the water mister. I'll go ahead and turn the water mister off by closing this valve. I'm going to open this disconnect up in case if I need to pull the disconnect out. Let's look at this guy for a second while I take some screws out of this. Now this is what it looks like. Now here's our water mister solenoid. It turns the water on and off, and it's really simple. It's these two wires right here. It goes to yellow and common. Common could be brown, blue, or black. The thermostat wire itself is blue on it, but the black wire here on the unit is actually common. It goes all the way up to this ORW2Y and then C. And then you can see they're all color coded besides common. So we know that my inverter won't run my air conditioner. Well, that's a shame. But it is a 42,000 BTU air conditioner. Now, I'm going to switch it back over to the grid, put our bar back on, and then I'll do some more tests with the water mister on the next video. This is Philip 20 with Guns, Games, and Racing, and I'll holler at y'all later.